Good morning, children. Today we will discuss about quality factor or Q factor. Let us go with the presentation. Okay, quality factor or Q factor. Quality factor, which is a measure of how much light from the gain medium of the laser is feedback into itself by the resonator. That means if we consider a resonator, we will obtain the light from the gain medium. But here, the light which is obtained from the gain medium of the laser is feedback into itself. That means again, the emitted light from the gain medium, again it goes with the input beam, and it again the laser process can be done here. That means here the light from the gain medium of the laser is feedback into itself by the resonator. That means we can observe a loss here. That since an optical fiber is open-ended modes, suffer losses which arises from. So here we can observe the losses from diffraction, spill over when the field undergoes reflection from the mirrors. So here the dissipation or loss of energy, simply Q factor is nothing but loss of energy. So loss of energy because we will obtain because of diffraction and reflection, scattering and absorption. So diffraction, so due to diffraction, spill over when the field undergoes reflection from the mirrors. So here also we can observe some losses in the energy. Finite reflectiveness of the mirrors. Because of reflection also we will obtain loss in the energy. Scattering and also absorption in the medium, which we have considered the medium. So scattering and absorption in the medium, filling the resonator cavity. So because of these diffraction, reflection, scattering, absorption, we will obtain the loss in the energy. So we will loss. So dissipation is nothing but loss. So the loss in energy is described in terms of quality factor or Q factor. Q of the mode is given by Q is equals to omega naught into energy stored in the mode by energy dissipated per second in that particular mode. That means here omega naught is nothing but 2 pi nu naught, or in omega naught oscillation frequency of a mode. So omega t, that means energy stored in the mode. Omega of t represents the energy stored in the mode at particular time t. So then from the definition of Q, omega naught, here omega naught into energy stored in the mode, omega of t, by energy dissipated per second in the particular mode. That means change in energy can be obtained. That means here change in stored energy, d by dt of omega t. So here negative sign represents the loss in the energy. So Q is Q of, if you take the cross multiplication, Q of minus d omega of t by dt, which is equals to omega naught into omega t. So d omega of t by dt equals to minus omega naught by q into omega t. So its solution is given by omega of t equals to omega naught e power minus omega naught of t by q. So if t represents the cavity time, so t is the cavity time, that is the time in which the energy in the mode decreased by a factor of 1 by e, then that means if t represents the cavity time, the time in which the energy in the mode decreased by a factor of 1 by e, the energy in the mode decreased by 1 by e, then so cavity lifetime, Tc is here cavity lifetime. So cavity lifetime is equals to q by omega naught, or omega naught is nothing but 2 pi nu naught. So q by 2 pi nu naught. Then the field associated with the mode is E of t equals to E naught e power minus omega naught t by 2q into e power 2 pi I nu naught into t. So this is the field associated with the mode. E of t equals to E naught e power minus omega naught t by 2q into e power 2 pi I nu naught into t. So by taking the Fourier transforms, let us consider Fourier transform. By taking the Fourier transform, we will obtain E average of mu is equals to integration 0 to infinity E of t e power minus 2 pi I nu t into dt. So this is by taking the Fourier transform. So by solving this, E of nu is equals to E average nu is equals to E naught by 2 pi into 1 minus nu naught plus nu naught by 2q, which is equation number A. So intensity I of nu is equals to this one, mod E average nu whole square. Let it be equation number B. So intensity of nu is equals to here E naught square by 4 pi square. So here intensity of nu. So this is equals to this one square and this one square. So we have to write I of nu equals to this E average nu. This is so E naught square by 4 pi square here, nu minus nu naught whole square plus nu naught square by 2q, 4q square. So let us substitute equation number A in equation number B. Now, so which represents this equation number 2 represents the Lorentz transformation. The intensity is maximum at, so nu is equals to nu naught. Whenever we have nu equals to nu naught, intensity is maximum. So here, hence, intensity maximum equals to E naught square. So if we consider this one, so here E naught square 2 pi, E naught square, here E naught square by 4 pi square, nu equals to nu naught. That means here this will become 0, nu naught square by 4q square. So intensity maximum equals to, so intensity is maximum only when nu equals to nu naught. So if we substitute nu equals to nu naught, this is 0. So E naught square by 4 pi square, nu naught square by 4q square. So intensity decreases to half the peak. That means intensity decreases to half the peak. Half of the intensity equals to half of the obtained value. So by equating equation number C and 2, we will get this one, half E naught square by pi square, nu naught square by q square equals to equation number 2 we have E naught square by 4 pi square, nu minus nu naught whole square plus nu naught square by 4q square. So if you cancel left hand side and right hand side, we will obtain q square by nu naught square equals to 1 by nu naught square, nu minus nu naught whole square plus nu naught square by 4q square. So if we cross multiplication, we will obtain. So if you make this here cross multiplication, nu minus nu naught whole square plus nu naught square by 4q square, which is equals to half this 1 by 2 and nu naught square by q square. And nu minus nu naught whole square equals to 1 by 2 nu naught square by q square minus nu naught square by 4q square. That means here, here this one. So nu minus nu naught whole square equals to, we are sending this one to right hand side here. So nu minus nu naught whole square equals to, by taking LCM, we will obtain 4. So 2 nu naught square minus nu naught square. So nu minus nu naught. That means we are sending this to, so square root nu naught square by 4q square. So nu minus nu naught equals to nu naught by 2q. So thus full width at half maximum is delta nu, which is equals to twice the half maximum. So full width, we have a condition, full width is twice the half maximum. So this is nu minus nu naught delta nu, which is full width is twice the half maximum. 2 into nu naught by 2q. So delta nu equals to nu naught by q. So here this is the line width, which is inversely proportional to quality factor. That means here we can observe the smaller loss in the cavity mode. That means if q is in the denominator, that means full width is inversely proportional to q, we will obtain the losses in the smaller losses in the cavity mode. Thank you. Thank you, children.